Visual programming done right. Preface. Above all, visual programming is power, and it should help you deploy to a self-provisioning bare metal serverless system that it manages, that you can actually modify to match your needs within the visual programming environment. When you are done laughing, understand that visual programming is the future. It's the only future. And the reason why you don't see that is because you have gotten used to how everything is incredibly broken. And nothing actually really works. Visual programming represents all of the much needed repairs. Let's not mince words here. Visual programming does replace the programming department. They will be missed. It scales. It works securely and reliably, and it is fast. It operates on the same patterns programmers use, but under a consistent, minimalist, and simplified user interface. That's right. Minimalism is the key to understand visual programming languages. You do not repair or enhance a visual programming language by sticking forms into the nodes. You ruin it. A visual programming language is just boxes, ports, lines, and labels. Just like there is an app for everything, that is its own world of buttons and functionality. In visual programming, there is a library of nodes specifically crafted to accomplish one thing well. Now, it is surrounded by a sprinkle of mostly reusable nodes that plug into it. But visual programming is domain specific. That means it is aimed at a single purpose. Critics, pipe down. A hacker is no contrarian. A hacker does not dismiss a technology, only makes it better. If you don't have anything positive to say, that just means you haven't learned something enough. Chill. The Linux command line is actually a visual programming language. Seriously, it's done with text, but it's a visual programming language. It both takes a lot and doesn't really take much to create a lot of function and power. But yes, there must exist large specific nodes for a specific domain. Just like in Linux, there must exist large nodes that do a lot of work and heavy lifting, but not all the work. These programs expose ports or attributes where a range of things can be plugged in. Timeout. Let me explain to you what a visual programming node actually is. On the left-hand side, you have properties like first name, last name, and on the right-hand side, you have outputs such as full name. So on the left-hand side, you're entering text. And on the right-hand side, you're executing a function to do something with that text. In this case, concatenate it and create a full name string. Okay? So That means that every output on the right-hand side is a function that takes in all the string arguments from the left-hand side, like first name and last name. So the output is not a string, it's a function, it's a little program. The input is a string, but it can be tweaked. You can edit it within the node. I think that's a common accepted way of dealing with things. But if you need to extend things more than just editing the default value, you plug in another node into it. And now instead of first name, last name strings that might have been there by default, Alice Smith, now, before your function on the right-hand side gets executed, it will spider up that line that connects its input port to some other node's distant node's output port, probably a string node that has a simple function that passes the string on, and it will have that output port execute and return the data that it will now use instead of the default string that it had in there before something was plugged into that particular port. So that means every output in a node is a function. Usually all you need is an output function, but you can also have uppercase output, lowercase output, debug output. You can have valid user or valid username or paid account or problems that require human intervention output port. And all of these would be little tiny programs that all have access to the arguments on the left-hand side. Yep. Oh, and if you don't like the idea of a function because you're more modern, then think of a visual programming language node as an object. Left-hand side are the properties. Right-hand side are the pertinent methods that do something with those properties. Okay, let's get back to business. Visual programming can be as low level as you need it, but often the lower you go, the more cumbersome the visual programming will get relative to throwing away the mouse and just freaking coding with your fingers. So eventually, in many instances, it does bite into standard programming because it's just easier to type than to drag the nodes in certain instances. There are exceptions here where you need to visualize something super complex, but mostly visual programming is for higher level things, when things get really complicated and they require holding things in your memory. They require graphs and charts and diagrams. That's what visual programming is for, visualizing high-level abstractions and the complexity that comes along with it. That is also the reason why you just can't keep the mouse away and code everything bottom up. Your mind is too limited. You need some kind of a map. That's right. That's what visual programming languages provide. A high-level overview of the entire system. And if you dare, then each and every one of your visual programming nodes would have an edit button and it would be visual programming all the way down. You see, visual programming is not a threat. It provides an interactive system diagram that also happens to be editable, making modifying the applications trivial and allowing for visualizing the way data flows through the system. You know how easy it is to debug a program where everything is animated and looks like freaking Mario running through all the nodes? It's a pleasure to see where everything is going. You don't need documentation when you can click simulate and watch your data packets slowly get routed through the system. The higher the abstraction layer, the more powerful the visual programming. A really good level full of tasty bits is the app world, where your nodes are on the level of phone apps, representing schedules, cameras, websites, feeds, and maybe company employees even. A really cheap way of making this happen is just wrapping third-party API in visual programming nodes. A lot of people are doing just that. But really, what those API endpoints should be is just another instance of a visual program. Now, out on the server, the code that will be running there will be generated by the visual programming language. It will look absolutely normal to the naked eye. It will be a minified program. That's all. But it will be built by another visual programming language. That's what high level gets you. It gets you the ability to crank out web services securely in a way where you don't create new problems, but prevent them from happening. Just a simple self-provisioning network. And it's simple because it's purpose-built for whatever you need. It's not a third party creating your HTTP servers with control panels and little dorky boxes for secure server certificates. It's just Express.js or some other tiny server, all secured and buttoned up behind a reverse proxy, maybe with some measure of packet inspection or even content inspection, just waiting to serve all your needs. Again, I must underline that it's not just high-level nodes that create powerful possibilities, but it is also a narrow domain that fixes problems that people actually have. A visual programming language that tries to do everything will do nothing right. Those of you who dislike the idea of putting in a large tool into your toolchain and then relying on it should know that yes, visual programming can run live during design, rerunning its payload every time a change is made, or something like a signal or writable or observable triggers. But it can also run under a play and stop buttons. So first you design your program and then you run it. But most importantly, it can very easily be used to generate source code, just like UML can generate your class code for you. I will leave you with a complex and enticing example of a money-making visual programming language. Instead of manually creating themes and UI kits for popular CSS frameworks so that you can sell it in their store, create a visual programming studio where you can build those themes by connecting boxes together. You can see how intimidating dealing with all the code generation can be. And this here should help you understand why visual programming. Why just squares, ports, labels, and long lines that show you where everything is plugged into? You need those diagrams to see what you are doing. The higher the abstraction, the greater the complexity, and thus greater the urgency to keep everything as simple, lightweight, and minimalist as possible. A good theme with lots of code snippets can sell for $50 countless times. That means no more work. That's great news if you're a teenager, because you can totally pull this off. To make new products, you just keep adding new nodes, sometimes enriching your existing products. And before you think to yourself that the design would all look similar and boring, just stop it. Be more positive. This is the future. You use one of the more popular image generators to create a new UI kit design. They're amazing at that. And then, you duplicate your latest, greatest product and begin modifying it to match the new designs. Here, I also want to interject that visual programming doesn't really force you into perfect minimalism. It's about keeping things simple, but also deeply useful. And you can see that in Blender. They have extra applets inside their nodes so that you get to do stuff while the nodes are showing on the screen. So in your visual programming language, you can create a box that will accept an image that was generated by an AI-based image generator that you ask to generate a beautiful UI kit. And then you just drag little boxes or crosshairs to sample colors, right? And now these colors are going to become outputs on the right-hand side. So you can drag them and plug them into the theme configuration. So you are pulling the colors directly out of a new image. Pretty cool. See, one of the rules for visual programming is that they have to be ultra useful, that they have to fix problems hard and fast. So you can have multiple kinds of nodes on your screen, including code editors. Cool stuff. Other somewhat notable examples are web scrapers, where you turn the internet into feeds by dragging and dropping things like tests to see if maybe the page has changed, and put together CSS selectors, maybe have a little preview on the side. UI builders, which also work with a split screen setup. See, a high-level user interface that uses nested components is just a tree. As in, this column has a form has inputs and a footer, and footer has a button. And a tree is what you connect together in a visual programming language. So, creating component-based user interfaces in visual programming has a one-to-one relationship. It's perfect. It's like the two are meant for each other. You can also create smaller, more useful tools for programmers. Build tiny HTTP servers like Express and Koa, where all the routing can be configured via drag and drop. And of course, music composition or music lectures with web audio and Tone.js. And maybe a visual tool for FFmpeg filter graphs that charges the customer $9 per month. And finally, tools that build, enhance, expand other domain-specific programming languages, primarily by creating new nodes that their customers can use. That means a visual programming language aimed at creating other domain-specific visual programming languages and expanding their node libraries.